Hi, my name is Christian Nansen. I'm an associate professor at University of California, Davis. I'm in the Department of Entomology and Nematology. And as part of the research and teaching that we do in my group, we work with pesticides, insecticides in particular, in many ways. And one of the ways we work with them is to collaborate with IR4 and industry partners on finding solutions that the industries need, and also expose the students to how testing is done, and how we can use novel technologies to move solutions forward and give the industries the pest management tools that they need. In my teaching, I take students to the field. We see the real world scenarios. We see flowering systems. We see orchards, crops. We see strawberries. We see many different systems, and we talk about the applied aspects, and we use it as part of the teaching that I perform. Also, there are hands-on lab sessions where the students get exposed to experimental designs and working with insects and pesticide testing, and using arthropods in these tests is a big part of the training that they receive, so that they can leave from this course, integrated pest management, that I teach every fall, with a better understanding of what pesticides mean, their role in pest management overall, and how they can be used judiciously in ways to both promote sustainable food production and also maintain the profitability of agricultural systems. At UC Davis, we have access to experimental greenhouses. I have 8 or 9 of them under my management. So we grow insects, we grow plants. So we have all the sort of, and we then have other greenhouses where we can do the actual experiments. We can also do outside field studies under different conditions. In the greenhouses, we have set up, we grow the plants individually, so they are individually irrigated and fertilized, and all the cages, as you can see, have a serial number, and they are being assigned to specific treatments. So we can randomize the distribution of plants within the greenhouse. We can subject them to different treatments, to different arthropod pests, and in that way obtain independent data, which allows us to statistically come up with more rigorous data. And we have enough space, greenhouse space, to replicate studies so that the statistical power of the data that we generate is quite high. We have in culture 2-spotted spider mites. We have western flower thrips, green peach aphids, silverleaf whiteflies, citrus mealybugs, lygus bugs. And then we also rear other insects for other purposes that are not sort of specifically related to pesticide treatment, but we do work with beet leafhoppers with and without beet curly top virus, so that's actually 2 colonies. We also have black soldier flies and navel orange worm in rearing. So in essence, we have lots of arthropods that we can use experimentally, that we can use in teaching, and that we can use in our collaboration with industry partners and IR4. In our greenhouses, as you just saw on one of the previous slides, we can set up in the neighborhood of 70 cages, individual cages, and they're all with fine mesh so that we can minimize the risk of cross-contamination or infestation in the individual cages. We can then assign them to different color-coded treatments, and we use that. There's a reason why I'm showing you these colors, because this is a big part of how we keep track of things and how we effectively come up with the experimental design that allows us to get the results we want. Because when we have typically an industry collaboration, we look at maybe 7 or 10 different treatments, and we use colors for each of them, or combinations of colors. And we then apply those colors to the bottles, the liter bottles that we use to make up our formulations in. so that everything follows a standardized procedure with colors. And this is very important both as part of organization of the trial, but also in terms of safety, because when you are wearing safety equipment, when you are wearing safety goggles and respirator and everything, it can be hard to see numbers, but using colors is something we found out that works really, really well. So all the bottles are color coded, all the different treatments are color coded, and then they are being applied by myself. I'm certified as a qualified applicator under we ensure high safety of everybody involved. So they are being labeled out, dispensed out in the bottles. We use the same bottles for each treatment every time, so we don't have any risk of cross contamination. And then when it's time to actually spray the plants, we bring them out of their cages, put them on the ground, use color-coded flags to make sure that we know that this is the color that, and we know that this is the number of that needs to be assigned to these. This is the treatment that needs to go to these particular plants. And then we use a standardized backpack sprayer to spray the plants so that they get completely covered. We can also apply the pesticide as a soil drench, which is basically just pouring a known volume of formulation into each of the pots. But in this way, we ensure that we get uniform and precision coverage and uniform coverage on all the individual plants within that treatment. We then collect either leaves or flowers, put them in ethanol if it's thrips, so that we can look at and count them afterwards. We then count both pests, so the density of pests on leaves or flowers, or we can do assessments of phytotoxicity if the products in some ways adversely affect the quality of the plants. And where we then start sort of getting into where we offer as an addition to the more conventional trials is we also can if there's a need for this, we can provide we can do additional studies where we look at choice studies. We can look at spray coverage, which is something we have done quite a bit of research on. We can look at behavioral avoidance, where we can see the effect of spray coverage. How does that affect the behavior and the distribution of insects on the plant? We can actually do life table studies, rearing the plants in growth chambers and figure out, in what ways is this sort of if we have some of the chemicals being growth regulators or in other ways affecting their long-term fitness, we can look into that. We have the capability of using Lycor 6400 to measure photosynthetic activity. We can take leaf samples and look at element composition or even do phytocompound analysis, so we can add the pesticide performance. We can add some plant physiological data and some plant chemistry data to give some idea of how these plants how these treatments are affecting the overall performance of the plants. We can also, and this is a big part of what we do, is we can do leaf reflectance profiling, also referred to as optical sensing, where we can basically, using a very advanced imaging technology, we can look at the reflectance profiles, and similar to essentially a crop doctor, we can take its temperature, or we can diagnose levels of plant stress in the plants, and that can be very important as part of sort of performance testing of pesticides. If we want to go beyond just looking at dead and live arthropods, if we want to know more about how the plant is actually responding, this can be done. And we can do this at multiple scales. We can do it inside in under controlled lighting conditions as seen to the left, or we can go outside where we actually have a rail system where we can place the pots and then use the same imaging technology on our robotic system and image them there. We also are working on the capabilities of using drones outside in field plots, so we could go at an even higher spatial scale. So in essence, to summarize, we have the capabilities of testing new pesticides, new formulations. We do that on a regular basis. It's a big part of what we do. We basically the most standard variables we're testing is phytotoxicity and pest suppression. How well is the product working? But we are also very interested in improving the current industry standards, especially when it comes to phytotoxicity, which is something that is very subjective and difficult to assess in a quantitative way. We're very interested in spray coverage and how that information can be used, and how we think that needs to be part of labels in the future, not just to say that this should be applied under conditions that ensure high spray coverage. Well, what is high spray coverage? That needs to be quantified. And what is the impact of not having a good spray coverage? We think that's very important. We're very interested in not just physiological resistance, which is something other labs work a lot on. We're more interested in the behavioral avoidance of how insects and mites have developed ways to avoid treated surfaces as part of their defense mechanisms. And we think that is also something that industries need to be aware of, and growers need to be aware of, so we can we can potentially find out ways that we can change formulations to minimize this behavioral avoidance. And then we think that it's very important that plant stress characterization goes into the performance testing. How is it affecting the element composition, the photosynthetic activity, and potentially can leaf reflectance be used in ways to not only see how the product, the formulations themselves affect the plant, but also how do they recover. So this is something we're very interested in. We're looking forward to hearing back from you. If you want to know more about our pesticide performance testing capabilities, you can contact me on this email, or you can visit my website. Thank you very much.